Alright, today's integral looks really scary. We have the integral of cosine x to the power of x. That's the scary part. And then times this big mess, ln of cosine x minus x tangent x. So where do you even start with something like this? And now, a thing that I've learned through practice problems like this, when you have something to the power of x in your integral multiplied by everything else, at least take an attempt to just take the derivative of that term. Because sometimes this part could be part of the derivative, and maybe that's all it is. So I'm going to let u equal cosine of x to the power of x, and I'll just rewrite it as in the form like this, rather than the normal trig form, just because it's easier to see. Now, how would you take the derivative of a term where it's the variable is x in the power? And there's a few ways. Some people use e and ln. The way I do it, I use logarithmic differentiation. So the way that works, we're going to take natural log of both sides. So ln of u equals ln of this whole mess. So cosine of x, power of x. The reason I do this is because ln of a to the b, where a in this case is cosine x and b is x, equals b ln a. So this, we just pull the power out front. So this will equal x ln of cosine x. On the left side, we'll still have just ln u. Now that we're done modifying, we can actually take the derivative of both of these terms normally. This is just going to be 1 over u du, or not du, 1 over u. Being more formal this time, this will be 1 over u du dx. Over on the right-hand side, we'll have to use product rule. So derivative of the first times the second will just give us ln of cosine x plus, just leave the first and multiply by the derivative of the second. Derivative of ln of cosine x, this will give us a negative tangent x. So I'll just write tangent right here. I'm going to rewrite this plus sign as a negative sign. Almost done here. We're going to multiply both sides by u to isolate our du dx. So this will give us du dx equals u times ln of cosine x minus x tan x. You're starting to see the resemblance up here. So all we have left is we have this u. We want everything in terms of x. So remember, u equals cosine of x to the x. So I'm just going to replace that. Du dx equals, because u is cosine of x to the x, cosine x to the x times this big mess. So ln of cosine x minus x tan x. And to make this nicer and the more u du kind of notation we see in integrals, I'm just going to multiply both sides by dx. Therefore, du equals all this mess dx. So remember, u equals cosine x to the x, du will equal this mess. Notice that this whole mess is exactly the same as the integrand. Therefore, we could just say all of this is our du. For replacing that in our integral, this will just equal the integral of du. Because this is all our du, we don't have an actual u term, but because we have the du, we could still do this substitution. So we're just left with the integral of du. Integral of du is, of course, just it's just u. That shouldn't have taken me so long. Yeah, integral of du is u. But u is cosine of x to the x, therefore our answer is cosine of x to the x. Don't forget, it's an indefinite integral, so we need plus c. But, yeah, that's all it is. It's the weird thing where you have a x in the power, so you gotta do a weird kind of u sub, but it actually works out really nice.